I'm Harrison. This is the video I wish someone had shown me before I shipped my first agent.
I built an agent. It calls tools, remembers context, follows instructions. Demo went great. Then a user typed, rename Ember to Infernia. One entity, one operation. My agent looped 15 times, burned through my API budget, and returned a response that didn't contain the word Infernia. I ran an eval suite, 5 test cases. Pass rate, 40%. Not on hard tasks, on things like rename one entity. The model was GPT-4 class. Plenty capable. I was blaming the model, wrong diagnosis. The core agent loop, perceive, reason, act, that's 10% of the work. It's the part every tutorial teaches. It's the part that works in the demo. The other 90% is what keeps it alive in production. Context management, memory, error handling, permissions, compression, circuit breakers. I read Claude Code's leaked source. The entire agent loop is 1,400 lines. The code base around it, 510,000 lines. That ratio is the 90%, and almost none of it is the model being smart. It's code making sure the model sees the right things and doesn't crash when things go wrong. Every production agent needs 5 things. Most teams only build 2 of them well. Planning and tool use. Those ride on model improvements. GPT 3.5 couldn't call tools reliably. Claude Opus can. You get those upgrades for free. Context and memory are where agents actually fail, and they're engineering problems. You can't model upgrade your way out of a pipeline that dumps 10 irrelevant entities in. That's not reflection, that's a diary. Here's what happens when you use the model the wrong way inside your own infrastructure. Claude Code's compression system had a bug. When compression failed, it retried, and retried, and retried. No limit. According to the leaked source, 1,279 sessions hit 50-plus consecutive failures. The worst one failed 3,200 times in a row. Globally, about 250,000 API calls were wasted every day. The fix: 3 lines of code, a counter, and an if statement. That's not a model problem. That's a code problem. And it's the kind of thing that lives in the 90% nobody talks about. What makes this tricky is that the 90% still uses the model, just not the way you'd expect. Claude Code's memory system needs to pick 5 relevant memories out of 200 files. It asks the model one question: which files matter? Gets the answer in 250 milliseconds and moves on. That costs about 256 tokens. The program drives. The model just answers. Its compression system is different. When the conversation gets too long, it hands the entire conversation to a child agent, a separate model instance with its own context, and says, summarize this. That costs 10,000 tokens or more. The program delegates. The agent delivers. And then there's the main loop. The model decides which tool to call. The program executes it. Result flows back. Model decides again. That's the part everyone knows. 3 patterns. Same model. Wildly different costs. The 250,000 wasted API calls I just mentioned, that was the compression pattern running without a kill switch. Choosing the wrong pattern is how you burn real money. This is the distinction that separates agents that demo well from agents that work in production. Open loop. You build a verification step. It detects a bad output. It logs the issue. Done. The user still sees the bad output. Closed loop. It detects the bad output, retries with the failure as feedback, and verifies again. The user never sees the mistake. Here's the test for your agent right now. Find your verification step. Does it log and move on? Or does it log, retry, and verify? The difference is one if statement, but it's the difference between having quality checks and actually catching errors. Half-built infrastructure is worse than none. It gives you I ran A/B evals on a production agent. Same model, same test cases, different code, 40% to 60%, 8 fixes, 7 were pure code, 0 LLM cost, context prioritization, structured error types, round limits, circuit breakers. The only fix that called the model was a planning step at 0.3% per request. For these tasks, the model was always capable. The context was suffocating it. This was a small eval, 5 test cases, not 1,000, but the direction is clear. Fixing the code around the model delivered more than any prompt change or model upgrade I tried. I want to be honest about where this hits a ceiling. One of my test cases was create a dragon, a knight, 2 locations, and a relationship between them, all in one message. 4 entities plus 1 relationship. Both the baseline and the improved version scored 0%. Same failure. That's not a context problem. That's a pipeline architecture problem. The agent creates each entity in isolation. It doesn't carry state from one creation to the next. The relationship creation doesn't know the knight was just created. Context fixes got me from 40 to 60. Getting to 80 needs architectural changes, collapsing the pipeline, adding cross-step state, closing the loop between creation steps. That's a different kind of work. So yes, fix your context first. It's the highest leverage move. But know that it has a ceiling. And eventually, you'll need to change the architecture, not just the input. That's next order work. Monday morning still starts with context. 3 things you can do Monday morning. 1. Audit your context pipeline before your next model upgrade. Add logging to see what the model actually receives. If it's full of noise, that's your bottleneck, not the model. 2. Find your verification step and close the loop. If it logs failures but doesn't retry, add the retry. 1 if statement. Do it Monday. 3. Run an eval suite on your current model before spending money on a bigger one. 5 test cases is enough to start. Measure, then decide. And the model is a commodity. The engineering around it is the product.
I'm Harrison. Full breakdown with source code references and the architecture diagrams PDF, both linked below. See you in the next one.